20 minutes. So we're going to dive in and we're going to go quick. So here's what's up. Your tests don't have, so Morgan, people, along with we've lost 10 minutes already, means I need you to pay attention and we need to start moving. Notice that the tests you got back don't have grades on them. No one is mastered yet. Okay, so how we're going to do this, if you have not turned these in yet, do it now. But aside from that, listen. Okay, because this is one of those weird Phoenix things. If you come to me and ask, what do I need for mastery, or to get mastery? I'll tell you, I don't know. Because it's really hard to define, right, what mastery is. So one of the things that I do as we, get to know all the Phoenix, things is on this first test and, occasionally, I haven't given you a grade because I want you to assess what you think you deserve. So, I've given you feedback. I've gone through and I've checked all your work, and we're going to go through and check it together again. You cannot write on your test paper. Okay, that messes me up for seeing what you did the first time versus with us in class together versus if you do it again outside of class. So today, the only writing you're doing is on graph paper. Okay, you're not writing on your test. You're looking at your test to see my feedback. So we're very quickly, probably about a minute or two per question, going to run through this. If you got the question right, awesome, but that does not give you permission to talk to your neighbor and distract the other people that need to be listening that maybe didn't get it right. Okay? Any questions on what we're about to do? There's no new homework. You are following along with me, and I guess I haven't said this clearly. If you missed a problem, you are revising that, doing it again on that graph paper. Okay? Because then you're going to, right now. Because you're going to turn that back in, and then if you give yourself a progressing, which is not a bad thing, that just means I need to go practice this a bit more. I'm not really mastered yet. There will be a progressing to mastery follow-up activity, which will be 5 or 6 questions of the main ones that people missed on here. So when you walk out of class today, you will have given me your test back with your graph paper attached to it. Okay, and we're probably even going to make you doing your revisions, potentially one of those intro activities or practice or whatever I can code it as in math, to make sure that you're following along with me. Right, so if you made a mistake, you're fixing it on your graph paper. You're redoing the problem. Zach?
Mine says see me.
Yeah, so I want to talk to you at some point. That's all that means. Okay. Yeah, so if you get a see me on your test, which you'll, all of you at some point this year will get see me's on your test, whether it's from me or for another teacher, just means we want to talk with you. We want to maybe ask you questions about how you process something, or something's really cool and we want you to explain it to us, or maybe explain it to the class. So that's all that see me means, is I want to talk with you. So most of us got number 1 right. If we're trying to convert 3/4 to 2 other fractions, we are essentially making proportions. We're saying, what do I do on top and what do I do on bottom? We need one with a numerator of 24 and one with a denominator of 24. So if you got this wrong, you're rewriting this on your graph paper. Or if you just want to practice and do it again for fun. What do I multiply by to turn 3 into 24? 6? No, that's 18. 7, 8. 8. So if that's times 8, I multiply by 8 down here, and that's 32. Over here, what I multiply by to get our 24, this one is 6, right? And that turns into 18. Any questions on number 1? Please make sure that you're working along with me. Number 2, some of us missed that was a question on the test. Because things are kind of close. So if you didn't answer number 2, I'd probably put a question mark out beside it, just saying hey, by the way, there was a question here. So how the test had it was circle the ones equal to, but I wanted you to think about each fraction and commit to crossing things out. There's only 2 here that actually match 3/5. It's the 30/50ths and the 9/15ths. The common wrong answer that people mark is 35 over 55. Guys, to get there, that would be times 11, and your numerator would need to be 33, not 35. Here would be a times 3 on bottom, doesn't work, and a times 101 would be the multiplication out here. this would, again, need to be a 3, and it's not. So the only two that are equivalent are those two. Questions? Sorry that I'm moving quick, but hey, you don't have any homework tonight.
Yeah.
So there's that benefit. If you did not show your work on this, I would ask that you write it out again and show your work. Because guys, you are asking to make mistakes later in the year if you don't get used to showing your work now. Now, what I mean by that doesn't need to be like a big task. Copy whatever doesn't change. Rewrite what does change. Like, you don't even have to show the times 2 times 2 and making new fractions, and then do the math. Now, the funny thing was some of us didn't notice that was subtraction. Eric?
Does the 7 incident count is already revised?
Does the what?
For the conversation you had with me about the 7.
Oh,
That
sure.
count is already revised.
Sorry, so here, again, we need to make common denominators. So sometimes, and when I say, like, I chuckled or I laughed when I was grading your papers, like, please never take offense to that. I just had enough of this happening. I was like, what did I do? A lot of you put that as your answer. Because you were just, like, going through it. Right? Like, that's not, we got to subtract here, guys. Not add. So it's not 13. How many 16ths should it be? 7. Should have 7 16ths. C and D, same sort of thing. We got to make common denominators. Notice that on this one, I only had you changing one of the fractions. Expect that on the next assessment, we'll be changing both fractions. Right? So this is the easier version of these problems, where I only have to say, oh, the 4 needs to become 8. So double, right? 6/8 minus 5/8. Again, this is subtraction 1/8. Again, if you missed these problems, you should be redoing them right now. This is like your freebie revisions. I have some people that I'm concerned about because they don't even have a pencil in their hand. My third, this is the only one that doesn't double. What does this need to do? Needs a triple, yeah, so it becomes 3/9 plus 4/9, and we end up with 7/9. Also notice none of those fractions needed simplified after we got the answer. Later in the year, we'll ask you, like, find the answer and simplify. So watch for that to happen. Any questions on our adding, subtracting fractions? Awesome stuff. This was one of the harder problems on the test. It really was. My best advice when working with mixed numbers. What do you think I'm going to say? Improper fraction. So for some of you that got it wrong, I think the main reason you got it wrong was you didn't work with improper fractions. And we've talked a little bit about this. And guys, this was not a trapdoor question, but give me your eyes real quick. The danger of subtracting fractions and even like mixed numbers is if I write out 16 and 5/6, and if I make common denominators happen, this would be 7 and 2/6. This problem is safer than other mixed number problems because I can do 16 minus 7 and get an answer, and I'm also actually able to do 5/6 minus the 2/6 and get an answer, and I can actually do my subtraction broken apart like that. You can't always. If this fraction is bigger than the first fraction, or when we talked about yesterday, you end up having to like borrow. So my best advice is make these things improper. So you have a calculator, right? But you need to show your work. Even with this multiplication, break it up. We get 60 and 36. So that's 96 plus 5 more, right? 101. Sorry that one's not completed. Over 6, I believe. Somebody check my work.
Yes.
And then 44.
Yeah.
Here's how you make this easy. Don't think about 101. Think about 100. 100 minus 44, well, 6 would take us up to 50. So 56, right? And then one more, 57. Some of you wrote down 56, and I just kind of circled it, and I wrote 57 next to it, because I think you just did your subtraction wrong. And you can leave it like this. We like improper fractions. Or you can go ahead and take it to the mixed number form. 9 and a half if we simplify. You don't have to unless you're told what form it has to be in. It's up to you. So guys, I like to give you a lot of freedom in your solving and how you present solutions and everything. Don't box yourself in unless like the instructions say so. Right now, this would have been ugly to try to solve using decimals. So really, make them improper, go from there. Here, our answer should be 4/15, right? Because we can make common denominators. The best work I saw, so if this is you, like give yourself a pat on the back, would rewrite these fractions over here, and this turns into 5/15. This turns into 6/15. Now, there are mistakes that were made that are kind of like not really mistakes because I know what you did. And guys, please, I know it's weird with Phoenix, but like you got to know we really do take time to like look at your work and like think about what you did and like what you were thinking. So when we grade your test, we're kind of like in your head saying, well, that's not 16. I can't talk and write. We're saying like, what could they have done? And that's what makes mastery grading kind of tough. Is we have to say like, well, was the mistake big enough that they really didn't understand the concept? If you wrote 11/15 as your answer, you're pretty much right. But you forgot one step. You forgot to subtract. Yeah. Right? Because that 11/15 is what these two pieces together are. This piece that's left is just 4/15. So always double check, like, does this make sense? If you put 11/15, don't beat yourself up, but that doesn't make sense. Right? This wedge is not very big, and I know sometimes things aren't drawn to scale, but that's, yeah. Always double check, does my answer make sense? The math is right? There's no mistake here, but that's not our answer. Our answer is 4/15. Questions? Almost every mistake that I saw on this problem was the same mistake, and it was from misunderstanding. So I really want us to pay attention here because this is the type of question, like a type of question you'll see on standardized tests. So some of you on your on my feedback have X's up here but checks down here. Right? And that's because you misunderstood what the problem was asking, but you did the math right. Right? Which is weird, but you got to carefully read and see what it's asking. The length of the missing section, most of you that have X's put where the section ends up here. So because we'll review how to do this again, right? Can anyone describe to me how we figure out what this is worth, what one tick is worth? Olivia?
We count how many spaces there are and divide by 5.
So 8, right? There are 8 spaces. So we take 48, divide by 8, 6, right? Thank you very much, good math people. And you we're not all as quick as each other, right? So we all have our strengths and weaknesses. So we number, can't talk and write. Wow, my brain was already on the 36 and it went ahead and wrote a 6. A lot of you put 30 up here. It's not where does the section end, it's how long is the section they've marked from start to finish. So if we start at 6 and go to 30, how long is that? 24. So if you put 30, I know what you did. You just misunderstood the question. So just kind of beware of careful reading. Now I know in your practice, a lot of the sections started at 0 and then went somewhere. Sorry, we're changing it up on you. So always be careful. Pay attention to what it's actually asking and make sure you're looking at it close enough to say, oh, that's different than the practice work. How big is each section here? 12. 12, right? Because there are 1, 2, 3, 4, 5 sections. 60 divided by 5. I might as well write that work here. That tells us the length of each section. So then 24, 36, 48. Can anyone tell me another way I could figure out the length of the missing section that isn't subtraction? Ella? Yeah, did you say add it up? Yeah, but there's a more efficient way even. Instead of adding multiple times, we could multiply. So we could say under this bracket, there are 3 sections that are each 12 long, right? Because we figured out that each section's 12. What's that come out to be? 36. Or 48 minus 12. 36. What's that mean?
I don't think that would be more efficient.
Well, it depends on how your brain. Some people like multiplication better. I don't want shapes. 16, our total length, divided by 4, right? There are 4 sections. So 16 divided by 4 comes out to be 4. So 4, 8, 12. And then this segment is, it's just one of them. So that's 4 here. I think almost everybody got the segment length right, but a lot of us missed this and like wrote 55 or 66. Each segment here is 11 because 99 divided by, there are 9 segments here. But then 33, 44, this is 55. What's 99 minus 55? 44. So be careful with that. I only have a couple minutes left, so we got to keep moving pretty quickly. This is a proportional relationship problem. So if you missed this one, what you wanted to do was set up the number of copies over the time it took. So 40 copies over 5 minutes, and those are not variables, those are like labels, right?
Yeah.
And they asked me how many copies in 30 minutes. The other thing you can think of is just what has happened to my time, right? If you're like, I can wash 1 dish in 1 minute, how many dishes can I wash in 30 minutes? Well, you think about the multiplication, right? 5 minutes compared to 30 minutes. What have I done to my time? I've multiplied by 6. So this multiplies by 6 and becomes 240 copies. In 8, the tricky part that hung up most people was this does not come out to be 100. And I did that on purpose because how is probability best represented? Fraction, decimal, or percent? What do we choose? Fraction. Fraction is the best way to represent probability. But percent is how we represent chance. Right now, probability and chance are like pretty much like twins, but probability is a fraction. So this comes out to be 22 over 102, 36 over 102, and then we put them together for the OR situation, and it's 58 over 102. You don't need to do that division. You don't need to put it into percent. You're fine. Leave it. Fractions are good. Fractions are a great way to show probability. So I'm going to go real fast. A, pay attention to it's greater than 4. So those numbers are just 5, 6, 7, 8. Who we appreciate. So even numbers, right here, even numbers, 2, 4, 6, 8. If there's 4 of each of them, it's equal. Now, a couple people wrote about, well, the group of 5, 6, 7, 8 is grouped, and therefore it's more likely because it's grouped together. Mathematically, that doesn't matter. So the group of 4 compared to the 4 spread out, they're equally likely. Here, 2 8s, and you could have left it as 2 8s or 25%. Some of us didn't quite pay attention to this problem. Like a few of us just missed that it existed. 4 blue out of 9 total. If there are 36 total marbles, what do I do? Times 4, right? We multiply by 4, 16. And then the area problems, if you need help with these, you can come and get help from me. The toughest one was this one. The trapezoid. It's half, and it doesn't matter what order you do this in. Base 1 plus base 2 times the height. So I need your graph paper stapled on top of your test, and then you can just stick it up here on the round table to make life easy. We've got 3 staplers.
I see you.
Here, Nick. And then we gotta get out of here. Sorry, we are at time. So talk to you later if you need. Yeah. Which? Oh, this should be 135. We will go over it on Monday. We'll go over the areas on Monday. Just turn in what you got right now. Graph paper on top, staple. Yeah. Hey, Zach, that needs to be AO extension. C can't happen now. Right. Sure, because you already edited it. You'll get it back. We'll use it for something else. On the table. Yeah, or you can try to do it at some point later, but there's no AO extensions today, so yeah, just we'll deal with it Monday. That's your work paper, right? Yeah, so just put the new one on top. Yeah. You're going to beta, whatever it is. Yes, today's paper on top, please. Because we normally go newest on top, so then I can put like grades on there.
Do you know that Greek alphabet? Like
Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, pi, omicron, pi, rho, sigma, tau, upsilon, phi, chi, psi, omega. I think I switched pi and phi and maybe another one. But yes, I do.